In this problem, we're asked to find all 6 trig ratios for the given angle. We're going to do part C. 17 pi over 3 is the angle. I want to think about how many rotations that is. I know that it's more than one full rotation, because one rotation would be 2 pi, and that's smaller than 17 pi over 3. I want to convince you of this. 18 pi over 3. What does that reduce to? Well, it reduces to 6 pi. 6 pi is 3 full rotations, right? Because it's 3 times 2. That gives us 6. So we should notice that our angle is going to be maybe just a little less than 3 full rotations by a third. So let's see if we can figure that out. So here I've got 1 full rotation, that's 2 pi. 2 full rotations would be 4 pi. 3 full rotations is going to be a third less than 6 pi. So this angle here should be pi over 3. That's the remaining amount of rotation that would get us all the way to 3 full rotations. Okay? So pi over 3, maybe you remember by now, is equivalent to 60 degrees. Let me convince you of that as well. So pi over 3, convert to degrees, 180 over pi. Pi's cancel. 180 divided by 3, well remember 18 divided by 3 is 6, so 180 divided by 3 is 60 degrees. So we have a 30, 60, 90 triangle with the 60 degrees is our reference angle. Okay, same thing, pi over 3 equals 60 degrees. So remember the angle, let's see, this one would be 30 degrees, this one's 60 degrees. So let's start with the side, let's start with r. We know r is always going to be equal to 1. Anytime we're dealing with ratios, in the trig ratios, we can use r equal to 1 because the ratio is always reduced down to a unit circle. The angle opposite the 30 degrees is 1/2. The angle opposite the 60 degrees, or the pi over 3, is root 3 over 2. But now we just have to remember what's negative and what's positive. R is always positive because it's a radius. The y component is going to be negative because we've landed in quadrant 4. Okay, so I like to list x, y, and r. X is 1/2. Y is negative root 3 over 2. R is 1. Okay, remember the properties that I know in a unit circle. The sine of the angle is going to be y over r. R is 1, so the sine of the angle is just y. The cosine of the angle is x. Tangent, y over x. And then cosecant, secant, and cotangent are the inverse, or the reverse of the first 3. Okay? So let's just find our ratios. Sine of 17 pi over 3 is equal to our y-coordinate, negative root 3 over 2. Cosine of 17 pi over 3 is our x-coordinate. It's a funny looking angle. Here we go. 17 pi over 3 is 1/2. Tangent of 17 pi over 3 is y over x, so negative root 3 over 2, all over 1/2. Invert the divisor and multiply. We're left with negative root 3. Cosecant. Negative 2 over root 3. Secant. Two. And tangent. Cotangent, that is. just do negative 1 over root 3 because I'm taking the inverse of tangent. Okay. To get these in proper form, as always, we can multiply by root 3 over 3. So I would get 2 root 3 over 3. Here I would get, multiplied by root 3 over 3, I would get negative root 3 over 3. So those are my 6 trig ratios for an angle of 17 pi over 3. Okay. Just a side note, 17 pi over 3 is the same thing as 1020 degrees. So if you like to think in terms of degrees, that's helpful.